right? Now here, let's look at the space are equal. The perpendicular lines are spaced equal, right? Plus the hypotenuse. Now, okay, if I take the third perpendicular also, I'll have one line up to the line x is x. Then I draw another straight line and I find that the distance between the y of the third perpendicular is also can be termed as y, and above that one will be my another y difference because all of them are spaced equally. So the difference between the first perpendicular and the second perpendicular line, say it is y. In my third perpendicular line, I'll have one y and one more y. That means I'll have two y over there because the y as measured for the second perpendicular line. The third perpendicular line, I'll have one y, two y. So that means my measurement of my third perpendicular line becomes x plus 2y, right? Now, when I'm having x plus 2y, there are two triangles created in this. Two triangles. That is A, B, C, and C, D, E, whatever you can carry out. Now, when you look into that two angle, the measurement of the hypotenuse side will be equal because the distance between first perpendicular and the second perpendicular line, or the second perpendicular and the third perpendicular line, all are same. So my hypotenuse should be same. The baseline of the other triangle will also be same between the two triangles. So what happens? This is a equilateral triangle, a congruent equilateral triangle. That means all three sides are equivalent or are matching to each other. Because my third side is y, and that is also y, but only to this y. So that means that my sides are equal. So it's equilateral congruent triangle. So when in that case, my y can just becomes x plus y and y plus 1 x y 2. So here my third line becomes x plus 2y. The third perpendicular line becomes x plus 2y. Now the reason for this is because the two triangles formed over there are equilaterally congruent triangles because the angles are matching. Everything is matching. They got one angle of 90 degree. The second angle, that is the crossing through the hypotenuse from the side to the other one, to the other triangle, will also be the same because both angles are congruent triangles. Now, when this congruent triangle, we take it, then all the three sides, three angles also will be equal. Now, in that case, it becomes my measurement is equal to each other. The sides measured are equal because this y and y1 is the same. Y and y1 will be having the same measure. Okay. And now the third and the fourth perpendicular are the same thing. The y1 and the y2, or the y from the first triangle, the second triangle, the third triangle, the y1 and the y2. That on the sides where I measured as y, and on the second triangle I measured as y1, and the third side I measured as y2. So all this y1 and y2 are equal as per the equilateral congruent triangle norm. All three are equal. Hence, what we get a sequence of measurement as x plus 1, x plus 2y, and x plus 3y. Right? And what's the common difference in this? Is the y. The y is the common difference in x. If you see, if I minus xy minus x, I get y as the difference. If I minus x 2y minus x plus y1, that is x plus 2y minus x plus y1. Here also I'm cutting a difference of y because now the 2y minus 1y is the term. 1y is y and x is 1. So x, the difference is y. Or if I take the third one, the same thing, I'm getting common difference of y. So having a same common difference in the sequence number of x, x plus y, x plus 2y, and x plus 3y, it is an sequence, an arithmetic sequence. This is how you need to prove this particular sum, right? If you get such sums on your question board, all you need to do, though we have nothing in our hand, we just had the measurement between the two perpendicular lines are equally spaced. That's all what you had. Now that equally spaced line is where we are getting it as x, x plus y, x plus 2y, and x plus 3y, which are sequence. The third one, the next question to you is, well, the next question, the sixth one. What he says is the algebraic expression of a sequence is xn. Algebraic sequence of an algebraic expression of an sequence, and the algebraic expression of an sequence is xn, which is equals to n cube minus 6n squared plus 13n minus 7. That's your sequence. That's your algebraic expression. And what's the algebraic expression? N cube minus 2n squared plus 13n minus 7. That's the algebraic expression of this sequence. Now here the xn is so and so. I need to prove whether this is a sequence or not, whether this it will come as a sequence or not. Now if the xn, instead of xn, if I put as x1, I'll replace all n as 1, right? Then here x1 is equals to, you can find out, is 1 cube minus 6 into 1 square plus 13 into 1 minus 7, plus 13 into 1 minus 7. And the answer you get when you simplify this, you get as 1. Right? Now let me put as x2 in for n, I replace it as 2. Then that becomes 2 cube minus 6 into 2 square plus 13 into 2 minus 7. Here I get a sequence and answer of 3. That is, what we do is we find n cube, that is 2 cube is 8 minus 6 into 2 square. 2 square is 6 minus 2 square. So that will become 6 into 2 square. The 2 square is 4. So 6 into 4 is 24. And then you have minus 13 to 2. That becomes 26 minus 7. When I calculate, when I plus or minus the whole term, the answer I get is 3. The third term, if I take it x as 3 instead of n, here I get is 3 cube minus 6 into 3 square plus 13 into 3 minus 7. Again, my answer over here is 5. If I calculate the whole thing, my answer, what I get is the 5. And the last, if I take x4 instead of n, if I take x4, and if I follow in the same procedure, in the same calculation way, my x value turns out to be 13. I find it with 13. This 13 will become, I get a sequence of 1, 3, 5, and 13. The difference between 1, 3, 5, and 13, is the common difference the same? Is what I need to understand. 1, 3, 5, and 13. Is the common difference the same? The common difference between 1, 3, and 5 is same. But between 5 and 13, the difference is different. We have a different difference. So that in that case, the sequence of 1, 3, 5, and 30 is not a sequence. It's not an arithmetic sequence. This is how we are able to understand it. That is, that sequence algebraic expression given to us was not under a sequence. The algebraic expression generated by an arithmetic sequence is not under a sequence. This is how you need to prove. If you get any sum in this factor, in this probability, these are two major things which I find it was difficult for you all to solve it. That's the reason why I'm doing it over here. The rest between 1, 2, and 3, and 4 is a very common sums. I believe you all can do it on your own. Just look into it, find out what formula you need to put in to find out xm or xn or x1 or x or the cd or the d. All those things you can keep finding out by using the formula. I hope you are able to understand it, and you can go ahead. In case you have any doubts, please let me know, because this is the first step as far as sequence is concerned. As a sequence, the next in the terms and position is the next which I'll be taking in the next class. I hope you all have understood it, and we can take it up. In case you have any difficulty, please let me know. We will clear it up. Okay. Thank you, and we'll see you then very soon next time. Thank you very much. Bye.